Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. And we are back with whatever. Let's see. So we have more comments here. Let's see. Malcha is wrong size. Is it always one though? I would expect it is 1 times size of char for chars, 1 times size of wchart for multibytes, and so on. But I'm not 100% on this. But I do not know for sure. I saw in code there already is a lot of sound code. There already are a bunch of const expr conditions to compile out UTF related things. So it is, well, I mean, he knows more about this, so I'm not gonna comment on this. Okay, let's see here. Okay, I don't know what else he commented here, but that seems to be it. Good. I think that's it for now. I will look at these things later. Yeah. Good. Then let's go to the code and do the things that we laid out in the last session. So we said that some things are not necessary to do. Yeah, so two tip markers. Yeah, so basically we revert all of this. Yeah, okay. So we reset this guy and we reset we reset this one and this one. Resets. Then we reset all of this here. Yeah, all of that. And I think we keep this stuff though. This is still useful. Okay, this one we use because that was good. And then we also remove this guy because it makes it more complicated than we need it to be. And then we also remove this one. And that would be it. Good. Good, then we go ahead in the third party and remove the small folder. That's it. Okay, so then let's see. Let's see if it still works. Seems to work. Good. There's one thing I wanted to test, and that is, like, I do wonder, will the printing towards this buffer always null terminated? I would think so. So in disassembled instruction, here there's a text. The textual human readable representation of the instruction guaranteed to be zero terminated. Okay, I think that means, so if we put here this 32 for testing, we should never run into a scenario where we get a crash. So basically we can compare. We probably will get some invalid opcodes now. Here, unrecognized opcodes. If it goes beyond the buffer size, that's fine. Let's go through all. Yeah, that passed. Okay, so this works. Then let's put it back. We could also make it even larger. Make it maybe 4 kilobytes. Just to be... Well, I think this is already outrageously large. 4096. Instruction buffer is extra large to give enough room instruction that would not fit in the buffer. You know, instruction I would not it is a bit lame that we put the label inside this instruction, so the symbol, like long function calls and so on, which balloons some of the instructions. Yeah, let's leave it like this. 4K, that's certainly enough forever. Good. Good. Is there anything else? So we have function. Right. Let's search for the assign formats. So we call this here buff capacity. Assign format buff capacity. I think here we can actually remove this one. Assign format. And then, and here we can do, we can also remove the cap. Append format, let me see. Here, output, initial size, initial capacity, resize, format to N. Okay, that seems to work. Good. Then let's commit this. So I say we make this one change here. So say improve formatting performance in function improve string formatting, improve performance of string formatting in Zion is disassemble codes. Improve performance of string formatting in Zydis in function class. We still need to check that we made no formatting mistakes here. Let's check this. So this is S. Okay, I see a mistake here. Function CPP. Okay, here we're missing an LL, and here as well. LL. Good. So this is, let's check this one here first. So this is unc, yeah, sub, yeah, symbol name, yeah, of, oh, here we have an error as well. Look at that. Operand PTR here. So this one was unc. PTR. Here. Unc. Okay. Let's double check. Stage. So now it's unc, yeah. Okay, sub. Symbol name of sub. Symbol name of sub. Symbol name of sub. Symbol name of sub. Symbol name, okay, and here we have quote S, quote SX, quote SX, S, SX, SX, plus S, plus SX, plus SX, S, SX, SX, S, SX, SX, S, SX with brackets, SX with brackets. Good. This looks correct now. Improve performance of string formatting in functions class. Good. Commit that. Okay, next. actually wonder, this thing, what does this return? It does return a string. But why is this compiled out here? What is this? Okay, well, it's going to the wrong function. Okay, it looks like we can't jump to this. It goes to the wrong function. It doesn't know what this is. That's unfortunate. Can we put a breakpoint here? Debug. Because I thought it returns a string, but in the profiler it looked as if it would return a stack string. So I do wonder what this actually returns. Here, if we, well, it returns the auto. FMT v11. FMT v11. Aha. Format. Okay, it does actually return a string here. Computer assign format. I actually think that it would not be necessary to use append format here at all. Because std string is so small here that it will just use the small string optimization. So we don't actually need to call this here. So I think we can simply do buff plus equal fmt format that. Yeah, I think that's good enough. Plus equal, yeah. And here we do buff. Maybe we don't use a sign, we just use equal. Buff equal fmt. Oh no. This one is a sign. This is a sign, yeah, okay. Yeah, so this is also just buff equal that fmt formats. Yeah. So I think this in the end means we don't actually end up using any of these functions here, if I'm not mistaken, which we have spent so much effort into crafting. Yeah, we don't use them at all. Well, okay, that's fine. That's fine. Okay, so use plus. Let's add a comment. Small string. We don't need this comment. Probably just adds more confusion. Good, let's double check it once more. Compare. Ta-da. Okay. Ta-da. Okay, cool. Okay, then simplify string formatting in Okay. And then here we, for now we just add it here. Maybe we remove it again if we really don't need it. Add more util functions to format to strings. Utility. Okay, the next step is we would like to add a clipper for the functions list and the bundles list. So it's an MGUI app, yeah. So we're looking for the clipper here. Let's copy this guy. So it's a clipper. And we're looking for to do. Oh, by the way, to do. We should have removed some of the comments here. To do, was it use stack string here? Make stack allocation. So we got this commented here and here. And create a fix-up commit for this. Commit. There we go. Main rebase. Auto squash. All right, there we go. Good. Next step is we need a to-do for clipper somewhere. Hold on. So add clippers to lists and tables. There we go. Add clippers. Do we have this? No, it's just this. Okay. Good. So we are looking at bundles lists. Bundles list here. So it's this guy, isn't it? Count. Now the question is, how do we use the clipper with that thing? So it's begin this size, clipper step, display start, display end. So old selection size, selection changed. I guess it's this one here. Yeah. So we probably have to substitute this code here with a clipper. Right. Begin count. Okay, maybe that's already enough. So that's a bundles list. Then let's go to the functions list here. So that's the same thing here and here. And also count, begin count. There we go. Good. Then let's see if that will work. I'm a bit suspicious because it's much different than our table. In our table, well, actually, it's not true. In a table, we also had a filter to remove elements. Let's see how this looks. I still don't understand how this works. Like, this to me is magic somehow. It really is magic. This clipper thingy. It's magic. Good. Let's see. So we are back in debug now. So the boot is slow. Good. So this looks fast, but we obviously need to see it in a debugger, in a profiler. Okay, so I see the clipper is working because we get the scroll bar as we move down here some of these entries. Right, like here, for example. Yeah, this makes sense. It's a bit awkward to scroll like this. Oh, actually, it's okay. It's okay. Yeah, I think this works well. Okay, this should be pretty fast. This is weird. Okay, but that's not our problem. That's something in ImGUI. It alternates the control bar in and out somehow. Probably because it's on the edge. Like it kicks in and then it changes position. Yeah, I think that's a problem. Yeah. Oh, it's not a big deal, I guess. Just a little glitch. Yeah. Well, it's a bit more than a glitch now. Yeah. I guess a way to fix it would be to make it always scrollable. Is that a thing? Let's see. Here, horizontal scroll bar. Maybe we make it always horizontal scroll bar. Here, functions lists and also bundles lists. Here. Let's add a comment here. Using using always horizontal scroll bar instead of horizontal scroll bar. Because list is glitching a bit with the clipper plus, because the list is glitching a bit when a clipped list is alternating between scroll bar on and off every frame. It's glitching. It's bugging. Or why is glitching not a word? Why is glitching not recognized? It's glitching. When the clipper makes it alternate between scroll bar on and off every frame. In some situations, okay. There we go. Good, then we have it documented. Let's try this. Compare. Good, so we always have the scroll bar here. And here. Good. And now it is no longer glitching here. Okay, nice. It does mean that we see a little bit less here now. Right. So that's maybe not so nice, but I mean, we can always resize it here, so it's not a super big deal, I guess. Okay, I think that's fine. Good, then we also need to look at clipping for the for the clipper step. So what is this function called? The Yeah, so the named function entries and the matched function entries, right? Function entries. Maybe all of them? Where should we put the clipper? Maybe in here? Disassemble it. Okay, well, the problem is here we have these two things happening before, so so this would have to be taken out of the loop. Yeah. Yeah. Yeah, so we first need to calculate how much is actually in there. So it says selected matched function indices. If not, is compared. We do this because it could still be processing, right? It still could actively compare. Yeah. Oof. This is this matched function. Selected named function indices. Yeah, is this? I would say the simplest here is we have like a for loop before this, and we just collect. We just collect these guys, but then it means we have to assemble a new list. Oof. Matched function. Yeah, but so probably in some still much more performant. Right. Yeah. Select name function indices. This this function, this thing here, how is this created? std move. std move. Okay. Free container selected. update selected named functions. It would be nice if we could just like build it once, right? And then just have it. But the problem is that disassembling could also happen from some other comparison window. So we cannot have like a clean callback. Unless we register like a callback to something, but we don't have this. Yeah, so the easiest is to just assemble it every frame here once. We could at least avoid the allocation. Selected named function indices is matched function continue. Disassembled. Yeah. Okay, so the problem is this here. It's disassembled. Right. Okay, let's do the naive approach for now, which probably will be fast enough. But yeah, basically, if we have like a huge selection, let's say we select 20,000 elements, yeah, then it would have to go through these 20,000 elements once and like make this check here. And then only afterwards we would have all the data for the clipper, right? Just because of this disassembling thingy. Yeah, okay. Selected named function indices. presented named function indices. Functions that are visible, functions that are presented with assembler So I would say the place where we create this guy, we do here dot shrink to fit free container and then dot reserve dot size. Okay, so we reserve a buffer, so at least we don't need to allocate it. And then program comparison, selected name function indices. Then we do also here matched functions that are presented with assembler in the UI. Links to matched functions. Presented matched function indices. Okay. And then we take this guy. Somehow we cannot search for it. Shrink to fit. Then we do util free container, this one, and then dot reserve dot size. Okay. Okay, so at least we have it allocated freshly here. And then we go to this function. Oh, is it? Oh. mgui app. There we go. So we are looking at here. So it has to be 2 paths. And here's fire, it's const. Oh. I don't like it updating every time. Can we do better? It's a first that we like update this every frame. It's not efficient. Maybe we don't need it. Let's first test what happens if we do clipping without this. We just do clipper right on this thing. Let's see what happens. I mean, what's the worst that can happen? Crash and burn. So we do... So we do clipper this here. And then named function index. Essentially this named function index equals this one. N. Then we remove this here. And put this and that. Okay, I'm a bit worried about this because maybe I don't know what will happen here. This could be screwing up the clipper, maybe, right? Let's see. Maybe it just leads to temporary glitches as a disassemble is in progress. I'm not sure. Let's see. Oof. Okay. I think it's because I think this error is because we have one entry. It has exited here, so it has no height effect on the height, and so the clipper recognizes this and then errors. Yeah, I think the problem is we cannot have anything in the clipper that doesn't have any element. Maybe we need to always draw the tree node in there, this one, but we don't necessarily draw this one in here. Would that be fair? But then, but then we have a tree node for something that has no body. That doesn't make sense. No. Shit. That doesn't make sense. Oof. Yeah, okay, so we have to get rid of these conditions. Maybe we need a callback for the disassembling. Or can we somehow... That's a problem. We would need to populate it before, but this is... Well, for the disassembling, actually... For the disassembling, I think it would be okay to put it here, yeah. Yeah, I think this would be fair, but for the... But for this one, not. So we would need to have... Selected named function indices. Selected named function. Okay, where's this guy set? Here. Selected. No, it's not that. We're looking at things that are not unmatched. Okay, so we are looking at selected all named. Selected all named. Reserve. Selected named. The question is, do we actually... Do we actually need to have... Maybe... Yeah, we need selected named. How about we create a also... Yeah, how about we create a selected unmatched named function indices, okay? And then put that here. We do selected unmatched named function indices. We do reserve that. Then we say here if is matched function, if not is matched function, then index TID, then we push back. There we go. There we go. Okay. Then we can remove this here. Then we do it. We assign it here. Unmatched named function indices. Okay. Yeah. Okay. And then let's remove this one here. And also this one. Okay. Let's remove this one. Okay. And here we have an error. There we go. Good. Okay, so this is already better. And now let's see if we can make that work. So the clipper, we put clipper. Where's it? It's wrong file, right? Where's it? Here. Yeah, okay, so now let's first stop debugging. So how about now we can remove this one because it's already implicit in selected unmatched named function indices, right? Okay, so that's already good. And now put this here. Let's make let's make a reference here. Selected const equals that. Let's call this named function indices, just so that we really make sure we use the same array here. Okay, and then we put this guy here in here, yeah. And then we put it, if is disassembled, then we call this function. Okay. Okay, and hopefully this will work. If it does, then great, because then we don't need any container building every frame. This should be very efficient then. Let's see. Compare. And yeah. Okay, it seems to work. It looks a bit glitchy because it appears too late. Okay, let's compile all of them. Okay, let's see how that looks. Okay, so far so good. We do get a little bit of glitching down here. Yeah, but it's not the end of the world. Okay, and now let's say we double click here. Oh, now that is weird. Yeah, I assume the problem is the clipper. I assume it saves an initial. Oof. This is unexpected, yeah. I have a suspicion as to why this happens. Yeah, it's not ideal. It's not ideal. Yeah, it's really glitchy. I suspect the clipper was not made for things that can resize or that are this large, right? So the problem is it's outside the view here, the top thingy. And I suspect that it only saved a record of its size when it was created, probably. Yeah, that's my suspicion. So when we resize it, it doesn't know the new size of it. Yeah. And then you get this glitch. Is there maybe a way to update the clipper in some way? Internal data, include items by index before first call to step. Include. Before first call to step. Okay, so this clipper is stateful in some way. So this internal data, somehow it's kept in ImGUI somewhere. Include item by index. See cursor. You can use ImGUI list clipper. Begin int max if you don't know item count ahead of time. Use minus to be calculated automatically. Items height. Well, the problem is our items height is dynamic. Use minus to be calculated automatically. Okay, so this list clipper was created with yeah. Okay, can we maybe do it in a different way? I mean, the other way would be we have to like cap the amount of things we show. Actually, it won't render things that are outside the view. But I think the problem is it goes through the whole thing and renders, or like says. So if we don't have the clipper, it goes through the whole thing and assembles all the different things, right? That's the expensive part. Yeah. Yeah, it is quite glitchy. If it was just for this, then I would say, okay, it doesn't matter much. But I think this is a problem. This is a problem. It really makes it hard to look at. Yeah, that's not good. No, we cannot ship the clipper like this. It's too buggy. It's too buggy. Yeah, it looks like it was really just made for fixed size list items, right? Like a table or selectables, things like this. Not for this kind of list. I guess it would work if we like had these like collapsed like this, but then yeah, we can uncollapse them, so that won't work. Yeah. 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 Okay, let's remove this here. So yeah, we can't use a clipper. Let's remove the clipper. Then we move this guy here. Then we can remove this and this and this. Okay. Then we do the same here. We move is compared to here. There we go. Let's say if tree is open and this. There we go. Revision. Guess we can also remove the revision here. Okay. So what we can say is that we, for example, stop at 50 or 100, right? If you have more than 100 selected, it doesn't show. We could do that. Just for performance reasons. Is there maybe a better solution? is open. Is open. String is open. Can we? How about it already has is content visible checks, so, and still that's slow. So it really is so slow to just go through all these things. Let's look at it in the pix capture again. Of course, we didn't launch it as administrator. Pix. So file open. So it was this one here. I hope the symbols are still shown. Yeah, so PDB just took less than 200 milliseconds. That's nice. Okay, so here's our main threads. We're going towards the end, and here it gets slow. So function entries, what exactly is so slow? Begin child. Begin child. Format string to temp buffer. Begin child. Tree node behavior. Yeah, so I think what is so expensive is that basically it calls the first child, so it goes in here and it does this here. There's a resize child. It starts with this one and that's what's so expensive. Yeah, we need to reduce the number of calls. But the question is how? We can't use a clipper. What we could do is, yeah, we could add a slider at the top, which says show page, like a page of things. So we have pages. Yeah. So you can still like select all these functions, but then when you reach a certain amount, like 50, for example, then it just pages it. So you can only see 50. So it only goes through 50 at max, or 25, right? Yeah, I think that would work. Pages. Okay. So we are probably looking at a widget, one of these things here, slider int, where you can flick through the pages with this thing, right? Yeah. Item picker, this one, call stack, slider int, here. Control plus click to input value. Slider int. All right. Then let's try to implement that guy. Comparison manager. Comparison descriptor. So imgui. Okay. So what I would say we do is we have an int imgui page size. imgui page size, and let's default it with 25. Okay, and then we make an int imgui selected page index, select page 0. Okay, and then we do this is selected functions page or presented functions page size and selection. Functions page. Or let's say selected functions or selected functions in pages. Okay. Okay, so then let's go to imgui app, function entries. So at the top you would have a tree offset. Yeah. So we would have the slider int. And slider int goes to descriptor imgui. Hold on. Page, selected page. Oh, it's const. Oops. Descriptor. Well, that looks like we have to make it not const. There we go. Const. There we go. Somehow it's still complaining. Why? Has no mem. What? Where did we add it? Oh, we added it in file. Oops. Oops. Oopsie. Here, imgui matched functions build. Oh, selected. Let's put it here. Okay. So the minimum is 0 and the maximum is the maximum we need to calculate. We need to calculate by selected. We're probably looking at this plus this. Let's add a function int get page count const. Get page count. Okay, so that would be that would be return static cast downcast util downcast. No, this downcast. Downcast get page count. So it is this one dot size plus m files 0 dot m selected unmatched dot size plus 1. Downcast int, and then this divided by page size. But that's not quite correct. Because there can be a fraction. But it also cannot be just plus 1. Let me see. Okay, how about we do size t size. Yeah, let's break it up a little bit. It's getting a bit unholy here. Okay, then we do for m files, for file m files, and the size plus equals file dot this here dot size, make it const. Okay, so we got this. Then we do size I think we have to say if size modulo this equals 0, then we simply do size divide by this. Otherwise, else size divide by this, and then plus 1. Size plus equal 1. Right? Okay, and then downcast size, and that's it. Okay, I think this is correct, but don't quote me on it. Size. Yeah, because essentially when there's no remainder, then we can just perfectly divide it. But if there is a remainder, then we still need to add one page because there will be some leftovers on the last page, right? And a number that does not quite meet the page size, right? So I think this is correct. I don't know, is there a way to write this better? Maybe, but I guess this is good enough for now. It's pretty cheap, I would say. Good, so page count, and then we put here int, const int, page count. Let's call it max page count. Descriptor get page count. Why it doesn't need max, it's just page count. Page count. And selected page. Yeah. So oops, no page count here. Get page counts. There we go. Okay, so this is select page, and then we should also have imgui input text. And we call this page size. And actually it shouldn't be input text, it should be input int or something. Hold on. Like a number field. Let's see. So we're looking at like this here. Input int. Drag int. Drag int. I think drag int is comfortable enough, right? Just drag it to like a reasonable number that you like. Yeah. Yeah, I think a drag int is good. Faster. You can type here. You can also type here. Okay, that's cool. Item picker. Let's also get this help text. I think that's useful because it's not really intuitive. Same line. I think we put it somewhere here into our imgui misc tooltip text. No, it's not tooltip text. Or is it? Tooltip text marker. Okay, ignore changes. Let's item picker here. Call stack. We're looking at this one here. Drag int. Drag int. Can we set a min max? Yeah, we can. Good. Then we put here drag int and a tooltip help marker. Click and drag to edit value. And yeah. Okay, here we're looking at descriptor dot imgui page size and maybe we do it at fiver increments, and then min max. Min is 0. No, 1. No, let's do 5. 5 is min. We do 1, 1. Okay, then we have this guy, and this should influence this guy. Page count. Maybe we just put it inline here. Actually, no, we probably need the page count. Drag int. Drag int max. Max 0. Page size. Okay, let's see how that looks. Now this will just draw the sliders. It won't have any functionality yet. Compare. So we have 0 page. 0 page. Oh. Oh. Division by 0. Okay. What did we do? Drag int. How did it get past? How did the page size get past 0? Past 1? We set it to put them into 1, no? V speed. Imgui slider flags. Logarithmic. Clamped 0 range. Clamp even if min max are 0. Otherwise, due to legacy reasons, drag functions don't clamp. Clamp 0 range. Always clamp. I think this is what we certainly want. I wonder if it doesn't clamp towards the top because we don't have an upper bound. Like, let's say we put here upper limit is something reasonable, 100. Let's see if that works. Hundreds, 1. Okay, so we need a max. I see, I see. The speed of this is quite outrageous. Maybe put the speed to 0.5 f. How about we make v speed? Let's do a const expr float v speed. Is that v min, v max, 100, min max v speed. Good. Okay, and then let's also add the flag. So we have const char format. %d. %d. And flags are imgui slider flags always clamp. All right. Let's see. Oh, hold on. We have a mistake here. That should be int. There we go. Compare. All right, so. All right, then let's try to type some -1 and it's clamped. Good. And the page is that. Okay, now select page is 0. Oh, well, page 0 doesn't make much sense. Slider in page should be 1. No, hold on. What is this? Min max slider select page min max. Min max. We could also just say here it's max int, right? V max int. How about we call it page size speed? Page size speed. Page size min and max. Page size min. Page size max. Okay, and then page. Slider int. Max. Page count. Yeah, so min is 1. And max is this max page count. Yeah. So slider int. Let's look at those imgui slider flags. I think we probably also need to put the always clamp then. So we have page count, %d, and always clamp. Select page. Okay, maybe we do put it inline here. 100. Okay, let's see if these controls are good. Compare. Good. So page size 100. Okay, we still have a 0 and a 1 here. Because page count, get page count. Page size. Get page count. Get page size. So this is 0. These are all 0 by default. Then this module with this. Yeah, well, it's just 0. It doesn't go in here. Zero mod 25 is 0, I guess. Yeah. Yeah. So we probably need to say here downcast, and then we do std min, no, max. Oh, really? Downcast, and then max 1. Yeah. So it's always expected to be 1. Always clamp. Okay, so the slider needs to be at 1 always. Right. It's at 0. Now it's 1. Because the default value is wrong. Select the page 1. There we go. What is this here, by the way? Pending. Oh, it's, yeah, some optimization, I think. Okay, let's see. Compare. Okay, there we go. Select page 1, page size. I think we can also take this -12 thingy here, which we have somewhere. 12. No. ngui app -12. Here, this one. Item width. Yeah. Let's put this here. Time make some spacings here. Let's move this using here. Actually, no, it should be at the top. Good, let's see. Compare. There we go. Okay, now, yeah. Maybe this should be in the same row here. How do we group things? Let's see. Basic. Group. Groups. Here, putting things next to each other. We can use just same line, but then I don't know what happens. Let's see. So let's say we put this here. Same line. What happens? Oof. Okay. That is not the expected. Let's remove this here. Compare. Oof. Okay, somehow, so either we need to create a table, or maybe there's some other way. Groups. Aha. Here we have multiple things next to each other. Examples, tools, item picker. Let's take a look at this guy. Aha, so they push an item width. And this is how it can be on the same line. So what happens if this goes smaller? I see. So it doesn't scale really. Pop, push, pop, push. Begin group. I mean, we can see what happens with the begin group. But I don't think that this will fix anything. Begin group. End group. I think we would have to put it into a table. Yeah, very likely. Yeah, this doesn't work. Okay, then table. Should be simple enough. Here, table. Okay, so we have 1, 2 indentations. 1, 2. So we put functions, pages, page options. Functions page. Next row, column index. And index here. I don't know if we can put this here, maybe. Oof. Jesus. Table. Next column. Oof. So next row, next column. Yeah, okay. Let's see if that looks all right. It is a bit overkill that we put the... Yeah. Oof. So this item bit somehow doesn't work here, so we probably need to put it here. Okay, so regarding the filter, it looks like we also need that there. Item width. Filter. Update filter. Page size, select page. Well, I think this is a bit confusing here, the way we put it. Because it looks like this would now affect this side and this thing would affect this side. But it shouldn't be like this. I think we should just put them one over another. But then we get more horizontal space. Okay, so I also see an issue here where we have this thing is not resizing the same way as these do. And curious why this one works. Oh, because the item width is here. I see. Item width. All right. Update filter. So what if we just put it here, up here? Would that work? Yeah. But on that note, let's see, where's this one being called? Here. That's probably fine. Good. I'm not a fan of this table here, so let's remove this again. Here and here and there and all this. This. Then let's remove this and this. And yeah, I think it's better this way. Good. So select page. So essentially now we select more things. Yeah. Oof, what is this? Okay, so we have 800 pages. And now if we increase this, yeah. $25. Okay, I wonder what was up there at the start with the collisions. Ah. I think it's because our change we made here with this one. Maybe. So so we probably want to do the what we had before. If not is compared, continue. Name function revision. If not, this is disassembled. Continue. Continue. There we go. All right. Name function. There we go. Ta-dum, ta-dum. Good. Let's see. That is all right. So yeah. Good. Then, so what is lagging now is this list here. Then let's implement the paging. So how do we do that? That's a good question. The paging spans across two different things: the named function indices and the matched function indices. So we cannot just have a span of some indices because also I think we need to have a function that returns us two spans. One span with selected matched function indices and another with this. And there's one page where we will have indices for both, right? Okay, but we should be able to calculate this. Let's see. Comparison descriptor. So we have a function get page count. So let's create a struct page functions page info. Or data. Functions page data. Okay, and there we put so we need a span const index t and matched function indices and and named function indices. Oof. Hold on. Oh, also we need, oh, it also spans across 2 files. Oof. Oof. So we need 3 spans. Huh. 3 spans. Hmm. Mm-hmm. Mm-hmm. Name function indices, let's call it 0 and 1. Yeah, and so we have a function get functions page data const. Rename. Oof. Get functions page count. Do we put an, do we give it an index? Functions page data. I don't think so. So we are looking at okay, this will require a little bit of brain to implement. I think we're already 3 hours or so in, yeah, almost. I think we'll take a break now and then come back fresh next session, implement this stuff. And hopefully it will be good. Yeah. Then we probably need to move these guys here into subfunctions because we need to call this one twice then with different indices. And yeah. Okay. Okay, yeah, there's still a little bit work left with the paging. Yeah. Okay, but I think we are on the right track here. This looks promising. All right. Anything else? No. Then that will be it. I wish you a great day or night. Until next time. Goodbye.